All right, so we're still in 8.5, and we're going to pick up where it started talking about the horizontal asymptotes. So I'm going to show you a few examples here. And they want us to determine the horizontal asymptote. All right, so let's see. These will pick up for y'all around number 11, 12, and 13, okay? So for 11, I got f of x is going to equal 2x to the third plus 5 divided by 3x to the third minus 5. All right, y'all remember, horizontal asymptotes depend on the degree of the numerator compared to the degree of the denominator. So I gave you 3 cases. So I'm going to look at the degree, which is my exponents. And for this example, the degree of the top equals the degree of the bottom. Right, so since both of them are degree 3, they're equal. So when it was equal, we said our horizontal asymptote equaled A over B, where A was the lead coefficient at the top, B was the lead coefficient at the bottom. Well, y'all, my lead coefficients are going to be 2 on top and 3 on bottom. So this horizontal asymptote wants to head towards 2/3 as it goes out towards infinity. It's going to try to get to 2/3. Now remember, in math lab, you got to put it in as y equals 2/3. Okay. And that's nice about horizontal asymptotes. That's all I'm doing is looking at those exponents. Okay. So let's try this one. We got f of x equals x squared minus 4 over 7x to the 4th plus 2. So let's look at our degree. On top, I got a degree 2. On bottom, I got a degree 4. So on this one, the bottom degree is greater than the top degree. So anytime the bottom degree is higher than the top degree, this automatically will be y equals 0. So remember, bottom heavy, it's going to be y equals 0 as your asymptote. So as this one goes out to infinity on either side, my graph is going to try to approach that x-axis. All right, so one more of those, and then we'll get into the graphing. So for 13, we got f of x equals x to the third minus 5x squared plus x minus 4. All of that's over x squared minus 18. So they just made a bigger problem trying to intimidate you. But y'all, all I'm looking for is these exponents. So on top, I got a degree 3. On bottom, I got a degree 2. So on this one, the top degree is greater than the bottom degree. So anytime that top degree is higher than the bottom degree, that is the case where it had no horizontal asymptote. So I believe in Math Lab, if you get an asymptote, it'll be like part A, and then they'll have an option B. If there's not a horizontal asymptote, just click B and then it moves on. All right, so for these next examples, they want us to find the domain, any asymptotes, the X and Y intercepts, and choose correct graph. So since I'm doing them by hand, y'all, I'll be drawing my graphs by hand and just show you what they should look like on these, okay? So y'all, the first one I'm gonna do is f of x equals 5x plus 2 all over x. So what's nice is when I find my domain and my vertical asymptotes, I'm pretty much doing them the same method. Then the horizontals, I'll compare the degrees, and then I'll show you how to do that X and Y axis, the X and Y intercepts again. So let's start with our domain. To find my domain, I'm going to set the bottom of this fraction equal to 0. When you set x equal to 0, there's nothing to solve. So the only number we got to exclude from our domain is 0. So we're going to write the domain in set builder notation. So everybody, when you got fractions like this, you're going to start at -infinity. From -infinity, you're going to go until the numbers you're excluding. So the number I'm excluding is 0. So we're going to union around that 0. And then from 0, I'm going to positive infinity. So my vertical asymptote. Notice I only got a single x factor in the bottom. The top, the only factor is a 5x plus 2. So that's not going to cancel out my asymptote this time. So my asymptote is actually the equation we solved for, which would be x equals 0. Remember, your vertical asymptote always occurs where your graph is undefined. Okay? Okay, so what's that? Leaves me with the horizontal asymptote next. So y'all on this one, you got 3 choices for my horizontal asymptote. Anybody want to guess what my horizontal will be since we just done those examples? I'm going to pull the chat up and see if I'm getting any response. So I'm going to leave you. Okay, I got it. Oh, you're really, really close. 5/1. There you go. Now you could actually reduce that 5/1 into just a 5 if you want to. So good job. Horizontal will be y equals 5. All right, so I've got my domain. I've got my 2 asymptotes. So now let's find that x and y intercept. To find the x-intercept of this graph, we set the numerator equal to 0. So that's going to give me 5x plus 2 equals 0. We solve that, that'll give us our x-intercepts. So y'all will solve that. we're going to subtract 2 first. We'll get 5x equals a -2. Then divide both sides by 5, and x will equal a -2/5. But y'all remember, when you write x-intercepts, they gotta look like a ordered pair. So x-intercepts always has the number first, -2/5, and then your 0. So once you get your answer, remember to put it in as an ordered pair. All right, so that's the x-intercept. So now I'll come up here and find my y-intercept. To find the y-intercept, you find f of 0. And to find f of 0, I put zeros in for all the x's. Oh, so y'all, what's happening to this y-intercept? I just put zeros into all these x's, but I've got a situation happening. Undefined, good job. So this is undefined. Since it's undefined, there is no y-intercept. But y'all, we knew that because over here, we said we're going to have a vertical asymptote at that 0. So you can't cross the line if you got a asymptote on it, okay? All right, so I'm going to give you a basic idea of what this graph will look like. So let's say I got a vertical asymptote at x equals 0. So that means on this y-axis, my graph cannot cross that line. Now my x-intercept is -2/5 and 0. So if this was say -1, -2, -3, -2/5 is going to be really close to that y-axis there. Well, that's where it's crossing the x-axis at. There's no y-intercept because we said we could not cross the y-axis. We had a vertical asymptote. So say we go up to what, 5? I mean a horizontal. So at 5 in the big picture, your graph is going to try to reach that 5 as my graph heads out to infinity. All righty, let's see if I wanted anything else on this one. All right, so on this one, it's not giving me enough with this information because I didn't get that y-intercept. So what we want to do is maybe find one more point in this to see what direction I'm headed. So y'all, I'm going to find f of 1. Now remember, if you graph these, you'll see the picture right off, and I'm going to show you on my calculator after this one, okay? So f of 1, I would put 1s in for those x's. So let's see what that gives me. 5 times 1 is 5 plus 2. That'll give me 7 over 1, which equals 7. So when I'm over here at 1, my graph is up here at 7. So now we pretty much got what's happening. This side is going to come down, cross the x-axis, and then head towards -infinity. This one's above that horizontal asymptote. It would come down and then curve and try to get on that horizontal asymptote. So let me draw this on the calculator and show you how you would put this in to help you. So I'm going to share the calculator. And I'll tell you the trick on this when you punch this in the calculator is to use parentheses when you got more than one part. So my top had a 5x plus 2, so I would definitely put that in parentheses. So 5x plus 2, and then divide by the bottom, which is just the x. So since it's just the x, I don't need it in parentheses. Now we'll say this. Remember, you could have hit the green alpha button and the y equals, and that would let you bring up n over d, which would make it look like a fraction when you put it in, okay? So let me clear my screen and I'll show you that. So that's the first way I would put it in. The second way, I can hit alpha y equals, go to 1 for n over d, hit enter. And that'll let me put 5x plus 2 on top. And then it'll let me go down to the bottom and put my x in. So either way, you can get that graph in there. So y'all, let's go look at the graph and see what we get. So there's that left side coming in, crossing at that -5/2 and heading down toward negative infinity. And then the right side, you can tell, comes in from positive infinity and then sort of tries to go to the 5 on that horizontal axis, okay? So y'all, I'm not going to lie, the easiest way is to really get good at that calculator, okay? Because it'll put them in and then you don't have to try to find all these extra points. All righty, so I wanted to do one more graph and show you a case where you get a hole in the graph. So y'all, this one will be f of x is going to equal x plus 2 on top over x squared minus 4. So I'm going to do something to this one. That top is already factored as x plus 2. I'm going to factor that bottom. So I'm going to factor that into parentheses. Anytime you got x squared minus a 4, that's what we call perfect squares. In the front of both parentheses will be an x. Since your last number is negative, you're going to have unlike signs. One will be positive, one will be negative. And then the number you put in each parentheses is what you get when you take the square root of that 4. Let me let one in real quick. So the square root of 4 is what, 2. So that means I'll put a 2 in each parenthesis. All righty, which means when I solve this for the vertical asymptotes, since you got a factor on top that matches this factor on the bottom, that's going to cancel that vertical asymptote. And it's going to create a hole in our graph. So when I get to the asymptotes, remember that, okay? But as far as the domain goes, I'm going to take the bottom of this and set it equal to 0. All right, take each individual factor, set them equal to 0. But y'all remember, quad would work on this. Quad, you can put in a 1, 0, -4, and it's going to give you the 2 answers I'm going to get by doing it by hand. So I get x is a -2. I get x is a +2. So my domain will come in from negative infinity until I hit that -2. Union around that -2 till I hit that +2. Union around that +2 till I hit positive infinity. So that's our domain. My vertical asymptote. Remember, the x plus 2 factor canceled out for your vertical asymptote. So the only vertical asymptote we'll have is going to be the x equals 2. Well, that's why you always got to sort of factor these when you don't know what the factors are to see if any of these cancel, okay? Any guesses on my horizontal asymptote? Because y'all got 3 cases, so y'all got one of them a while ago when y'all had that 5. What y'all putting on this one? Well, I like that. Okay, you're good to go. So y equals 0 is perfect. And remember, it's y equals 0 because the bottom was a degree 2. The top was really a degree 1 since we didn't have an exponent. So bottom heavy is always y equals 0. X-intercept. Well, I'll find the x-intercept by setting that top equal to 0. But guess what? Right here, we said that this was undefined at that factor. So if we set that top equal to 0, it's going to give us x equals -2, right? But we can't have a 0 where it's undefined at. So that means there is no x-intercept. Remember, you cannot have an x-intercept where that graph is undefined at. And that's actually occurring where we said there would be a hole in the graph, okay? All right, let's see. Y-intercept. Y-intercept, I find the f of 0. So that's going to be 0 plus 2 on top over 0 squared minus 4. So that's just going to give me 2 over -4, which I'm just going to make a -1/2. So the y-intercept will be 0, comma, -1/2. All righty, so let's see if we got enough to draw this graph. So here's our x and our y. Now remember, the calculator will spit it out quick. Remember, in the calculator, though, put parentheses around the top and the bottom since you got more than one part in each, okay? All right, so let's see. I'm going to go out about 3, I think. The only vertical asymptote I have is at x equals 2. But I do know that since this asymptote canceled out with the top, over here at -2, it's sort of going to have a hole in my graph. Okay. Now, my horizontal asymptote over time, this graph is going to try to come down to the 0, which is the x-axis. My y-intercept was 0, -1/2. Well, 0, -1/2 is right there. So now this one's not as bad because we can sort of see that it's coming in from that hole. It's going to cross the y-axis right here, and then it's going to head down. It's got to head down because it's not crossing that x-axis anywhere else. Now, this side just sort of comes up and tries to get on that x-axis, which means this side will come in on this side of that asymptote and try to come down and get on the x-axis to the right. So y'all, let's graph that one real quick on my calculator. And we'll go to y equals and clear that. So I'm just going to go to old style. I'm going to use parentheses. I had an x plus 2. Close parentheses and then divide by parentheses x squared minus 4. All right, y'all, then what? Graph. So we hit graph. And there you go. Notice on that left side, it came in and then it goes down toward negative infinity. The right side's coming in from the positive infinity. Now notice you cannot see a hole on the graph, but if you look at the table, which is second graph, and let me set my table real quick. I want it to be started, let me clear that. I'll say -5. And then I'm going to go down and change it. Instead of going by halves, I'm going to go by ones again. Remember, we were setting them up so that we could do the fraction ones last week on the zeros. Okay, look here at -2 on the x's, you get an error. That's where that hole happens. Okay, because it's undefined right there. All right, y'all, so that was the rest of 8.5. So we want to get now into 8.6.
Can you explain again why on the vertical asymptote on that last one that we did, why it was 2 and not -2?
Oh, because on this one, when the only reason I could use the 2 instead of the -2 was because this factor, the x plus 2 factor on the bottom, cancels with this x plus 2 factor on the top.
Okay.
And anytime you got factors that cancel, it's just going to make a hole there and not that actual asymptote.
Got it. Thank you.
Okay. All right, so to me, 8.6 is not as difficult as what we just went through with these fractions. 8.6 deals with polynomial inequalities. So I got to remind you of a few things because we're going to be doing interval notation with these inequalities. So remember, if it's greater than or equals or less than and equals, in interval notation, we use brackets. Second thing, if it's greater than or less than only, and it does not have the equals in it, we're going to use parentheses. Now just remember this, infinity always has parentheses around it, okay? So y'all, let's write the steps to solving polynomial inequalities. So the first thing you want to do is solve the equation by setting it equal to 0. Because remember, these are going to be x squared. They're going to be quadratic. And anytime we got quadratics, set it equal to 0. And then you could use the quad formula if you want to, okay? All right, next, once I got those solutions, I'm going to set up a number line. Using the solutions. Okay, so I'm going to get two answers. We'll set me up a number line. Then what I'm going to do is choose a test point. If the test point is true, then you shade that section. If the test point is false, then you're not going to shade that section. So there's two cases that can happen. So these are my two solutions, A and B. Either this is going to shade in between the two solutions, or it's going to shade to the outside of those two solutions. But it's got to be one case or the other when you got two solutions, okay? All right. Once I've tested my test point, now I'll tell y'all the truth. The test point I always use is 0, because 0 is the easiest number I can plug in and figure out quick, okay? All right, so once I've got my test point figured out, I'm going to write the answer in interval notation. But we got one thing we got to watch out for. If we only get one solution, then that is the only number excluded from the domain. Maybe not domain, but how about that's the only number excluded from the solutions? Okay. So our trick is going to be getting these solved and then testing our test point. So these will say solve the inequality. And y'all, also there was another case, and I'll show you when I hit that one question. It's what happens when we consider it a no solution, okay? So let's go on the first one. This would be like y'all's number one, I guess. X minus 4 times x plus 2 is less than 0. So they've already factored this one. They're just getting you into the other steps first. But what you want to do, since it's already factored, it said each of these factors equal to 0. All righty, solve each of these. Add 4 to the first one, subtract 2 from the second. So I get x equals 4. X equals a negative 2. So now it says set up a number line using those solutions. So let's see, negative 2 would come first, and then my 4 would be to the right. And those are the only numbers you need on your number line, because they're the only ones that mean anything. Now you can pick a test point out of any of these regions and test it. So I always use 0, because I know 0 is in between that negative 2 and 4. So I'm going to test 0. To test 0, I put 0 in for these x's and see if this is true or false. So that would give me 0 minus 4 times 0 plus 2 has to be less than 0. So y'all, is that going to be true or false? Well, number keeps curving up on me. I see a cap. What's that one? All right, so watch this. -4 for that parentheses, +2 has to be less than 0. Well, definitely going to be false. I see it now. So -2 is -8 less than 0 is false. So what that means, I'm going to redraw my number line here so that you're not confused when you look at your notes. So let me ask y'all this. Y'all said false, but I'm going to override that. Because really, -8 is actually less than 0. So that would be true. You know, I was starting to look at that and I was like, oh no, we got a -8 there. yeah, you're not tripping, girl. So since it's true for where the 0 was, we're going to shade in between -2 and 4. If that was false, then we'd have shaded the 2 outer edges, okay? All right, y'all, so here is our interval. We'll have -2 on one side, 4 on the other. My question is, will I use brackets or parentheses? Oh, good job, parentheses. Because there's no equals under that inequality. So since there's no equals under it, we're definitely using our parentheses. And y'all, that's all MathLab wants is that little answer right there. Okay. I'll show y'all another trick on this one. I'm going to graph this and show y'all another trick I do. So let me go to calculator, go to y equals, and I'm going to clear that. I can put in that equation that was x minus 4 in parentheses. And then I had parentheses and an x plus 2. And then close parentheses. Now remember, this was less than. So what I'm looking for is what section of this graph is less than the x-axis. So watch this. Go to graph. And y'all see this part that's under? It starts going under over here at -2. And it stays under the x-axis until I hit +4. So if you graph it, the only thing you got to figure out is whether you're putting it in them parentheses or brackets, okay? All righty, so that's just another way you can sort of check yourself on these. All right, y'all, so this one has x squared minus 13x plus 40 is greater than 0. You can hit this with the quad, 1, -13, and 40. I'm going to factor it real quick. You got an x squared, that means an x and an x. The last one's positive. Since that's positive, both of these factors will have the same sign as the middle. Factors of 40, that'll add to give me 13 or 5 and 8. Right, so -5, -8, add to get -13. They multiply to get me a +40. So now I'm just going to set these factors equal to 0 and get those numbers. So it looks like I'm going to get what, a +5 for the first one. And a +8 for the second. So we're going to set up our number line from 5, and then 8 will be on the right side. Now check this out. If I test 0 this time, 0 is not in the middle this time. 0 is going to be over here in this left side. So 0 is going to be before the 5. So here's the thing. I'm going to test 0. If it's true, I'm going to shade it and the last section. If it's false, I'm only going to shade the middle. So here we go. We're going to have 0 squared minus 13 times 0 plus 40 has to be greater than 0. So I'll just go back to my original equations and plug in my zeros. Or you could have used this one where we had it factored. You could have put zeros into that. All right, so let's see. We get 0 squared minus 0 is 0. 0 plus 40 is 40. So this is saying 40 is greater than 0. So y'all, that is definitely true. So since it's true for 40 being greater than 0, here's my number line again, 5 and 8. Since 0 was true, we're shading the front section and the last section. So remember, there's no equals under this, so I'm using parentheses for everything. This one comes in from negative infinity until it hits that 5. Then it's going to union from the 8 to positive infinity. Okay, also, they're not too bad once you get them factored. But remember, y'all could be using the quad for these, okay? All right, how about this? X squared is greater than 9. And then remember, the trick on this is always, if you want to use a quad, you got to get a 0 on the right side. So if you want to use quad, you would subtract 9 from both sides, and you would get x squared minus 9 is greater than 0. So quad would be 1, 0, because there's not an x in the middle, and c would be negative 9. I'm going to factor that because that's imperfect squares I showed y'all a while ago. You got an x squared in front is an x and an x. Last number is negative, so you got unlike signs. Square root of 9 is 3, so you get a 3 and a 3. And y'all solve those for those x's. Basically, I'm going to get what, a negative 3 and a positive 3. So negative 3 and 3 will be on our number line. So here we go. Negative 3 will be on the left. Positive 3 on the right. This time 0 is right in between these two numbers. So I'm going to test 0. So you can use any of these equations you want to. You can do the first one and say 0 squared is greater than 9. True or false? So we're saying false on that, right? So since it's false, we're not going to shade where the 0 was located. We're going to shade, we cannot shade where the 0 was since that was false. So we're going to shade the outer edges. Okay, and like I said, it's either the center or the edges, okay? Now, this one does not have an equals in it, so it's not going to be brackets, it's going to be parentheses. So from negative infinity to that negative 3, union from that 3 to positive infinity. All right, y'all. So these aren't probably as bad as doing that graphing stuff, right? With the fractions. So y'all, I've got two more. This is a pretty short section for you. So I'm gonna knock out a couple more for y'all. Oh, I'm gonna try. How about this one? 25 minus x squared is less than or equal to 0. So y'all, things I do to this, I like that x squared term first. So I'm going to rearrange it so that I get negative x squared plus 25 is less than or equal to 0. And then you always want the x squared term to be positive. So anytime it's negative, divide everybody by that -1 to make this thing positive. So I got to do something else since I divided by negative, right? Anytime you divide an inequality by negative, you got to reverse that inequality so that it's now going to be a greater than or equals. You got to move it when you do that, okay? So now we get x squared minus 25 is going to be greater than or equal to 0. Quad would be 1, 0, negative 25 for your A, B, and C. But y'all, we should be able to factor this thing really quick now, right? What y'all think that's going to give me? But I've done 2 of them for y'all. And that's those perfect squares. -5 and 5. There you go. So you'll have x minus 5, x plus 5. And then when you solve it, you're going to get exactly those answers. So good job. So add my 5. There's the 5. Subtract 5. And there's your -5. So good job. So let's make our number line. We got a -5 on the left side, +5 on the right side, and I know 0 is right in between. So usually what I do, I go to one where we're actually rearranged it and everything, and I would use either one of these 2 equations. So I'm just going to do 0 squared minus 25 is greater than or equal to 0. Which basically says -25 greater than or equal to 0. Y'all, that's why I use zeros, because anywhere there's an X, it's just going to become a big 0. But y'all, -25 is not greater than 0, so that's false. So I'm not shading the middle where the 0 was located. I'm going to shade the outer edges. Now, if you pick any number that I'm shading and you put it into that equation, it will make it true, okay? All righty, so let's see. We're going to start at -infinity, and we go to the -5. Let's see. What do I want on this? Around that 5. Well, around that -5. Do y'all want parentheses or do y'all want brackets? Definitely, I want brackets because it's got equals in it. So you would put a bracket, then your union, and then a bracket around your next number, which would be the 5. And then from 5, you're going to infinity. So good job on that. All right, y'all. One similar to that, 10x minus 25 minus x squared is less than 0. I'm going to rearrange this one. put the negative x squared first, the 10x second, the minus 25 has to be less than 0. Now, I don't like that negative in the front, remember? So I'm going to divide everybody by -1. So I get x squared minus 10x plus 25. Remember, divided by negative, so flip that inequality, make that a greater than, and then 0 divided by -1 is 0. So at that point, quad would be 1, -10, 25. But y'all watch this. X squared, that's an x and an x. Last sign's positive, so both my factors will be negative like the middle number. Factors of 25, that'll give me 10, would be 5 and 5. But y'all look, I got repeating factors. So I'm just going to solve this one and get my number. And remember that whenever I get only one answer, that's the only number I'm going to exclude from my domain. So we go to +5 and x equals 5. So if you did a number line, all you got the 5 there, right? So that means that this was one of them graphs that would have came down and would have been tangent to the x-axis. Okay, remember that had a degree 2 there. All right, so here's a trick. It only touches in one spot, so your domain is going to go from -infinity up to that 5, union around that 5, and from there you're going to positive infinity. Okay, now if that would have had an equals on it, you would have probably got about the same answer, right? So the only difference is if I had an equals, I could have took that 5 as an answer because it would have made it equals. So that would have been one of those where it was all real numbers, okay? But all y'all got to know is this. If it only has one answer, you're only kicking out that one number, okay? So let me show you the last type of an example. I've got an x squared plus an 8 less than 4x. Remember, I need a 0 on the right side. So at that point, I would subtract 4x from both sides. That would give me an x squared. And I'm just going to put them in order. Minus 4x plus my 8 is now less than 0. So y'all, if you get quad, you would be 1, -4, 8. So I'm just going to try to factor that real quick. So I would have an x and an x. The last number is positive, so both of these would be negative like the middle. All right, so can y'all find me factors of 8 that add to get me a 4? And I'll tell you the truth, if you did this on quad, 1, -4, 8, you're probably not even going to get real numbers for that. Let me see. So I'm going to hit it with the quad. So A was 1, B was -4, C was an 8. Oh, y'all, look at that. I get 2 plus 2y, 2 minus 2y. Those are imaginary numbers. So that means this thing does not factor. Since it does not factor, this is what we call a no solution. In Math Lab, to do a no solution, they want you to, on the bottom down there where you got the fractions and exponent helper tools, they'll have a 0 with a line through it. That means no solution. Okay, so the main thing, get these on one side equal to 0. Get them factored somehow, either by hand or by the quad. Test your test points and then figure out your intervals. If it's only got one solution, then that's the only number you're going to exclude from the domain. And if it does not factor, we use what we call an empty set or no solution. So I think you'll like 8.6 better than you like 8.5. All right, y'all, so here's our plans. We're going to come in Tuesday and we're going to review for test 3. And I think I've already got the study guide open. The study guide will have 25 questions on it. My test will only have 20. Okay. So what I do on the test is I take some of them really long questions out where they're asking you for the domain, X and Y intercepts, vertical, horizontal. That's too much work on the test, so I take some of them out, okay? All righty, so I've probably messed y'all's head up enough for today. So y'all, like always, we will send this video in a couple of hours. This is the last of test 3 material. So any questions? And I had some on there last week. Did y'all get, Tuesday, I don't see if it's any of them that I sent the program to though, so never mind. All righty, y'all, so I'm going to shut this down and I will see y'all Tuesday night.